In lesson 4, we're looking at solving linear equations with the distributive property. So if you remember in our polynomials unit, we did use the distributive property. It's just a multiplication property. So what it means is that we multiply each term in the bracket by the term outside the bracket. This can also include distributing a negative sign if the number in front of the bracket has a negative. Remember, the bracket means multiplication. Okay, so again, I'm not going to go through these steps so much right now. They're just there for reference for you to look back at once you understand them. It's just going to be a little bit more straightforward if we jump right into working with solving the equations that we have, and then you can go back and reference these steps and this example for maybe your cheat sheet or if you need a quick refresher on those steps. So let's look at example 1. Example 1, we are solving. Again, the only difference from what we've done before is that the x is in a bracket. So we cannot get x by itself when it's in a bracket attached to another number. So the first step is to get rid of the bracket using the distributive property. Again, we did this in the polynomials unit. We're just going to look at the left side here, 2 times x minus 10. And to get rid of that bracket, we're going to distribute the 2 by multiplication. So the first thing that we're going to do is we're going to ask ourselves, what is 2 times the x, which is 2x. The next thing we're going to ask ourselves is what is 2 times the negative 10? So that's negative 20, and that represents the arrows that multiply to get rid of the brackets. Equals, we haven't touched anything on the other side, it still equals 10. You can now see that this has left us with something that we're very comfortable with. We've been working with this already. We want to solve for x. We need to get rid of the 2 attached by multiplication. The 20 is attached by subtraction. We do reverse BEDMAS, so we're going to get rid of the subtraction first by adding 20 to both sides. So on the left, we're left with 2x, negative 20 plus 20 is just 0, equals, on the right we have 10 plus 20, which is 30. We're not done yet because x is not by itself. The 2 is attached by multiplication, so we're going to divide by 2 because then that equals 1. Whatever we do to one side, we're going to do to the other. So we end up with 1x now, so just x is fine. 30 divided by 2 is 15, and that's our solution. All right, so at this point, I'm going to get you to pause the video for about a minute or a minute and a half, and I'd like you to try B, and then we'll check in on it together. So for B, we're doing the same steps. We need to get rid of the brackets first by multiplying. So 4 times y is 4y. Next, we're going to multiply the 4 by the negative 2, which gives us negative 8, and all of that equals 12. We need to get rid of the 4 that's attached by multiplication, the 8 subtraction. We're going to do the opposite. So the first thing we need to do is get rid of the 8 by adding 8 to both sides. On the left, we have 4y. The negative 8 plus 8 is 0, equals 12 plus 8, which is 20. Our next step is to divide both sides by 4. So we end up with 1y, because 4 divided by 4 is 1. We don't need to write the y. 20 divided by 4 is 5. All right, so you'll notice for example 1 and B were very similar. We just had one step of multiplication, and then our equations were just 2-step equations. Example 2 is just a little bit trickier. The only real difference that you're going to notice is that we have an extra number that is on the side of the brackets, either by addition or subtraction. So our first step is going to be the same. We're still getting rid of the brackets first. So that plus 7 in example 2a, we're not doing anything with that yet. I've just highlighted it to note that it's the only difference between the previous question. So I'm going to erase that now just so it doesn't confuse us. And we're going to start with exactly the same first step. We're just going to distribute the negative 3, so make sure that you attach that negative in your multiplication. So we have negative 3x minus 3. Negative 3 times x and negative 3 times positive 1. We're now going to keep that plus 7, and we're just going to write it in its same spot. We're going to keep the equal sign and the 5x. After every step, we're going to look at the left side by itself and the right side by itself and just see if there's anything we can simplify on the side where it already is before we start moving things around. So my next step, I noticed that before I start moving anything on the left, I have some constants. So let's just put those together. Negative 3x minus 3 plus 7 is plus 4 equals 5x. Notice that I'm not changing any signs here because I'm not moving anything across the equal sign. They're already together, so I'm just doing the simple addition or subtraction. So the other thing we might notice now is that we have x's on both sides. So now we're bringing back in lesson 3. So we need to get the x's together. Because there's only a 5x on the right, I'm going to choose to move everything to the right. You can choose to move either way. This will just have a few less steps. So I'm going to get rid of the negative 3x from the left by adding 3x. Whatever I do to one side, I do to the other. So the purpose of this is to get rid of the x's on the left and have all the x's on the right. Again, if you choose to go the other direction, that's totally fine. So on the left now, I just have 4. On the right, I can combine 5x plus 3x because they're like terms. I have 8x. I want to get x by itself. It has an 8 attached to it. So now remember, what I'm trying to get by itself is on the right side of the equal sign. So make sure you're dividing by the right number here. It's very common for people to want to divide by 4 because that's just the first number that they see. But what we're trying to get rid of, what we're trying to cancel or make 1, 8 divided by 8. So now we have 4 over 8 equaling x. 4 over 8 is the same thing as 1/2. So 1/2 equals x. This one is a little bit trickier because it is bringing in that new grade 9 concept of having variables on both sides. So let's try b together before we kind of start doing some on our own. So for b, your first step, again, is to multiply by the 6. Just what's in the bracket. The plus 10 equaling 10x that comes after that is going to stay the same. So 6 times x is 6x. 6 times negative 4 is negative 24. Again, the plus 12 equals 10x stays the same. Now, before I move anything over, is there anything I can simplify based on where things are? And the answer is yes. I can just make this easier by combining the constants. So 6x, negative 24 plus 12 is negative 12, equals 10x. Okay. Now I want to get the x's all to one side. Again, it's your choice which direction you want to move, but because I noticed that the 10x is by itself on the other side, I just think it's easier to go in that direction. So I'm going to get rid of the 6x by subtracting both sides by 6x. So on the left, it's now 0. Minus 12, don't forget that negative is attached to the 12 there, equals 4x. Now I need to get rid of the 4 attached to the x by multiplication by dividing both sides by 4. So negative 3 equals x. Okay. So as you can see, we aren't really doing anything new here other than combining previous concepts that we've already learned, which of course always makes the work a little bit harder because the more steps that we have, the trickier it can get. But really, it just comes a lot with practice. If you look at example 3, the only thing we're doing here is an extra set of brackets. Now we have multiplication on the left and the right, so we need to use the distributive property on both sides. So let's start on the left. So we're going to start by multiplying the 2. So 2 times x is 2x, 2 times negative 1 is negative 2, and then we have our equal sign. We're going to do the same thing on the right. We're going to take the 4 and we're going to multiply it in. 4 times x is 4x. 4 times 1 is positive 4. All right, at this point, we're good to start combining things to the same side. I like to get the x's together first. Some people like to get the constants together first. There's really a few different ways you could do this. As long as you're showing your work, the work is correct, and we're all getting to the same place at the end. So I'm going to choose to move the 4x over by subtracting 4x. Whatever I do to one side, I do to the other. Notice when I do this subtract 4x on the left, I'm putting it underneath the x that already is there. So what I mean, don't write this down, I'm going to do it in a different color, is I'm not putting the 4x with the negative 2 like I did in the purple because I can't combine negative 2 and negative 4x. So make sure you're writing it with the like term to make your next step easier. So in my next step now, I can see that I can take the 2x minus 4x and I can combine them. 2x minus 4x is negative 2x. I then have this negative 2 here that I haven't done anything with, equals, on the other side I just have 4. This should now be something that you're comfortable to solve on your own because this is middle years. This is our review we did. This is just now a 2-step equation. We are going to start by getting rid of the subtract 2 by adding 2 to both sides. So now on the left, all we have is a negative 2x, and on the right, we have 4 plus 2, which is 6. We're now going to get rid of the negative 2, which is attached by multiplication, so we're going to divide by negative 2. Make sure you're dividing by negative 2, because otherwise, if you just divide by 2, you're going to be left with a negative x, which is not completed. Okay, so now we have x equaling negative 3. All right, let's try b together. First thing we're going to do is multiply the 3 on the left. 3 times p is 3p. 3 times negative 2 is negative 6. Equals. We're going to do the same thing now on the right, but keeping in mind that we're distributing a negative 3, so we need to account for that sign as well. Negative 3 times p is negative 3p. Negative 3 times 4 is negative 12. Now we're going to start combining some like terms. If you look at just the right, 3p minus 6, there's nothing I can put together there yet. If you look on just the left, or sorry, the right, negative 3p minus 12, there's nothing I can put together. So I'm going to start moving things over. So I'm going to move over that negative 3p by adding 3p to both sides. Again, note where I'm writing them. I'm writing it with the p's so that on the right side I can show how it is 0, and on the left side I now know what I'm combining for my next step. So on my next line, 3p plus 3p is 6p. The minus 6 doesn't change, equals, and now on the other side I just have negative 12. This is now a two-step equation to solve for p. We're going to add 6 to both sides. 6p equals negative 12 plus 6 is negative 6. And we're going to divide both sides by 6 to get p by itself, so p equals negative 1. All right, so as you can see, as we move through example 1 to example 4, every time we're just adding a little bit trickier concept, just a little bit more work, a little bit more steps before we get to that two-step solution. Let's look at example 4. We've got more brackets, okay? But on top of this fact that we have 2 brackets, we also maybe have some extra numbers here. And as you notice in example 4a, both brackets are on the left side, but in 4b, they're on opposite sides. So we're going to look at how to approach this. So let's start with 4a. The first thing in our first step we're going to do is we're just going to multiply both the brackets to get rid of them, okay? So let's start with the 5. 5 times x is 5x. 5 times negative 5 is negative 25. Now let's move on to the negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 4 is plus 8. Equals 4. Now this is where things get tricky, because what I want you to notice is that the 5x and the negative 2x are already on the same side. So we are going to combine them without changing any signs. 5x minus 2x is 3x. I did not have to move anything across the equal sign to put these together, so none of the signs change when I combine them. The exact same thing happens with the minus 25 and the plus 8. They are already on the same side. Do not change any signs. Minus 25 plus 8 is minus 17. On the other side, I just have the 4. Now we need to start moving things around to get x by itself. This is where we start working with the opposites. So to get rid of the minus 17, we're going to plus 17. Now we have 3x equals 21. We're going to divide both sides by 3, and we're left with x equals 7. Don't forget, you can always check your work by taking your answer and plugging it back in to make sure that the left side equals the right side. All right, let's try b. So again, remember, we need to do the multiplication first. The most common error that I see here is wanting to change this 5 plus 2 to a 7 and then multiplying the 7 into the bracket. So please make sure that you make a note to yourself not to do that, because the only thing that's actually being multiplied here is the 2. So that 5 is just an addition that's happening after we get rid of the brackets. So we are going to first get rid of the brackets. The 5 is staying exactly the same. So let's start with the left side. 3 times x is 3x. 3 times negative 4 is negative 12. So that's it. We're done on the left. The 5 is staying the same. We are not adding before we multiply, because we're currently still doing forward bed mass until we can simplify this to solve for x. Okay, we're not doing anything backwards yet. So now we're going to multiply that 2 in. So plus 2 times 2x is plus 4x. 2 times negative 1 is negative 2. All right. So now let's look at the left side, 3x minus 12. Before I start moving anything around, can I put anything together there? And the answer is no. But let's look at the right side. Again, before I start moving anything around, notice that I can make this simpler by simplifying the constants. 5 minus 2. They are already on the same side of the equal sign. I'm not moving them anywhere, so I'm not changing any of the signs. 5 take away 2 is just 3, okay? I find that students tend to start like adding 2 to the 5 because they think that they need to write it right underneath. That's only when we're moving across an equal sign. If we're working with things that are already together, we're just doing it using the signs that already exist on it. Now I need to get the x's together. So again, it's your choice. Do you want to minus 3x from both sides, or do you want to minus 4x from both sides? I'm going to minus 4x from both sides. Okay. Notice where I wrote it. I wrote the x with the x so that in my next step, it's easy for me to see how I'm combining my like terms. 3x minus 4x is minus 1x, and then I have the negative 12 there. On the other side, I now just have a 3. Okay, I'm ready to get x by itself. Now I'm starting to do reverse BEDMAS. So get rid of your subtraction first by adding 12 to both sides. So negative 1x equals 15. This is why I put the 1 there. You don't need it. You can just call this negative x as you go along the way. But I do find that sometimes if you have a negative x, you tend to forget that that does mean you have an additional step, because we need to get rid of that negative that's attached by multiplication by dividing, which ultimately really just means that if you change the sign on the x to get rid of the negative, you need to change the sign on the number on the other side. So if it was positive 15, it's now negative 15. And that is solving by adding the distributive property.